Hello, I am Subaki, CTO at Hamada Labs. Our platform, named WindyFlo, utilizes block-style no-code operations to easily serve AI LLM models through complex neural networks. With WindyFlo, you can arrange how to utilize these complex neural networks and LLM AI models into blocks. These blocks can be shared and pulled from various clients, enhancing their utility across different platforms. Moreover, we provide these services in API format to ensure they are usable for clients. As you can see, once you log in and click Get Started, you can view the home screen with sections like My Workflow, Repository, Credentials, and API Key. On the home screen, WindyFlo's LLM recommends a model workflows tailored to your needs, enabling semi-automatic design. Upon accessing the repository, you will find various nodes connected to different AI neural networks. For example, if you explore the Auto GPT, you will see a variety of options available. We will now demonstrate how our platform can be used to create specific use cases. Thank you.
Hello, my name is Haiyan Siobe, a student at the Department of Software at Sungsil University, class of 2019. If I were to summarize our service email roadmap in one sentence, it would be a unified email management service. I will explain more during the demonstration. Initially, during the sign-up process, users register their Google and Naver emails with our service. Skipping over the sign-up details, I will use a pre-created test account for this demonstration. In the complete mailbox view, you can see emails from linked accounts on one page. Currently, we are only integrated with Google and Naver, but we plan to include other platforms in the future. In the keyword mail section, you can filter emails by registering interest keywords. For example, if you enter the keyword GitHub, emails related to GitHub are automatically categorized, making specific emails easy to find. Lastly, I will discuss the email sending feature. Using WindyFlo, AI automatically generates email templates. When you enter the desired email format in the prompt window, WindyFlo provides a template. Upon clicking Add, WindyFlo AI composes the email content in HTML format. When sending, you enter the recipient's email address and use the Google or Naver account you registered during the sign-up stage to send the actual email. As you can see in my inbox, emails are received in real time. The part where WindyFlo service is applied is when providing email format templates during sending. To assist users unsure of how to compose their emails, simply input the desired subject or style into the prompt, and WindyFlo offers its services accordingly. The first step involves checking if the email format related to the user's prompt exists in our database. Email formats can be stored as CSV files in the database. You can select a CSV file to upload, and after uploading, the emails are well distinguished using a character text splitter with a customer separator. These sorted emails are then placed into a vector database called Pinnacle. Since CSV files are not inherently machine-readable, they must be converted into vector data that machines can understand easily. We use a node called OpenAI embeddings to convert the data into easily understandable vector data, which is then stored in the Pinnacle database. User prompts are input into AI chat models like Anthropic or OpenAI, which are then connected below to Pinnacle in a conversational retrieval QA chain. This intermediary utilizes various features like model, vector data, and memory input moderation, currently serving as the mediator in our email roadmap service. If the database lacks the user-inputted email format, AI automatically generates a template. These nodes are where AI directly creates email templates. As mentioned earlier, user-inputted prompts are fed into the AI chat model, and through the prompt template node, the user data is structured into an email format. Also, backend and frontend developers can easily handle this through a structured output parser that specifies the JSON data output, with many output parsers available to receive data in various formats. Lastly, the three nodes are connected using an LLM chain to produce well-structured outputs. Especially in AI-related functionalities, while the actual API integration process typically requires communication with clients. WindyFlo simplifies this by merely entering a line of WindyFlo API in the source code, fetching the API address, and calling according to a predefined format, thereby receiving the desired output data effortlessly. The most useful aspect of using WindyFlo has been the ease of implementing desired functionalities using nodes. For instance, when using translation APIs provided by Naver or mapping APIs by Kakao, the data must be modified or extracted according to the API's output. WindyFlo allows these functionalities to be implemented in an easily understandable node format, receiving data in the desired format, thereby enhancing development freedom and simplifying data processing. From the perspective of work efficiency and productivity while developing the email roadmap site, consider how time-consuming the process would be without WindyFlo, storing email formats in the database, fetching them, receiving user prompts, and measuring content similarity. All these parts need to be interconnected, a task readily accomplished by adding just one line of WindyFlo API, thereby completing in one day what would typically take a week to develop. I highly recommend WindyFlo to developers and colleagues, particularly for students like me involved in graduation projects or contests where using AI technology is common. Given the fixed deadlines in contests or graduation projects, being able to utilize these AI technologies while saving time can be significantly beneficial. From this aspect, as well as from a technical perspective, junior developers can gain a lot through a single line of API related to these AI functionalities. So, I highly recommend WindyFlo too. Thank you.